Imagine you are standing in the middle of a forest so vast that it stretches on forever in every single direction. No matter where you turn, your eyes are met with a wall of timber. Even if the trees near you are spaced far apart, as you look deeper into the distance, the gaps between the trunks begin to close. Eventually, every single line of sight would inevitably end at the surface of a tree. In a forest that never ends, the horizon simply wouldn't exist. You would be surrounded by a solid, unbroken wall of wood. Now, take that image and replace those trees with stars. Look up at the night sky. Our universe is filled with hundreds of billions of galaxies, each containing hundreds of billions of suns. If the universe is truly as vast as we believe, then every single point in the sky should eventually hit the surface of a star. Every tiny gap between the stars we see should be filled with another star farther away. Under these conditions, the night sky shouldn't be a dark, empty void. It should be a solid, blindingly bright canopy of light, as hot and brilliant as the surface of the sun itself. Yet, when we look up, we see a deep, silent blackness. The darkness you see between the stars should not exist. This is more than just a visual curiosity. It is a profound scientific mystery that points to a fundamental truth about our reality. The reason space is dark tells us that the universe had a beginning, and that it is still changing in ways our eyes can barely perceive. We must investigate the heavens' reasoning to grasp this. Local street lamps are brighter than those a mile away. Scientists use the inverse square law to explain light dispersal. Stars far away may appear too dim to light up the sky. That logic fails given the universe's immensity. Imagine an onion-layered universe with Earth at the center. A distant star may appear 4 times fainter than a nearby one. Due to its size, that distant shell has more stars. The many stars in that distant layer compensate for their reduced brightness in a uniform cosmos. The universe should illuminate our sky evenly from every distant stratum. Light from all those levels should illuminate the sky if the universe is infinite and full with stars. This philosophical puzzle is Olbers Paradox. Night should be as brilliant as day if the cosmos is unchanging and eternal. Astronomers struggled for centuries with this conundrum because it implied our basic understanding of the universe was wrong. Scientists thought something was shielding the light, but that made things worse. Before finding real remedies, we must address the most common causes. Most people think space and stars are too big and distant. Light doesn't fill a room instantaneously at cosmic distances. Distance alone cannot solve the problem, as the shell model shows. Unlimited stars would fill every millimeter of the sky regardless of distance. Second most popular theory, dust and gas fill space. As we know, nebulae and cosmic dust clouds block light. Dark dust rifts blanket the Milky Way's brilliant core. This logic is terribly wrong. If the universe were eternal, starlight would hit dust clouds forever. Dust would heat up and reach thermal equilibrium with that energy. The dust would shine as brightly as the stars it hid. It starts dark like charcoal in a fire, but turns brilliant like flames. Finally, the huge empty distances between galaxies are often noted. And limitless, unchanging universe should have something illuminating in every direction. These common sense responses fail physics. Each theory fails. We must reimagine time and space to answer the black sky enigma. Space's darkness can be solved by acknowledging the universe's finite age. Humanity thought the universe existed forever, yet it's 13.8 billion years old. This is groundbreaking since light travels 300,000 kilometers per second. This is fast, but cosmic distances are more impressive. Moon image from 1.3 seconds ago. This is the sun 8 minutes ago. Telescopes reveal faraway galaxies' billion-year histories. Because the universe is finite, we can only see so far, the visible universe. Imagine standing on a huge field during a midnight lightning storm. You can only see flashes that cross the pitch. Lightning from 50 miles away may still be coming if the storm started minutes ago. Some stars and galaxies are too distant for Earth to see their light. All of the universe outside our light bubble is invisible. Our universe is young and has a beginning, not endless generations of stars. Limiting time is only part of the solution. After accounting for the universe's age, some ancient light reached us, but we can't perceive it. The universe is expanding, the second explanation pillar. Astronomers realized in the early 20th century that faraway galaxies are moving away from us everywhere. The space between galaxies is expanding. Light waves extend as they travel across this expanding area. This is cosmological redshift. Imagine a wave-drawn rubber band. The wave lengthens and the peaks separate when the rubber band ends are pulled. The wavelength of light controls its color and energy in physics. Blue and violet wavelengths are shorter than red wavelengths. Infrared, microwave, and radio waves are created when light is extended beyond the red end of the visible spectrum. More distant objects' visible light shifts into these longer, invisible wavelengths as space expands. Each photon loses energy as the wavelength expands. The light is weakening and changing color. By the time light from the farthest areas of the universe reaches our neighborhood, it is too stretched to see. The universe glows in brightness our eyes cannot see. Radio waves or microwaves would illuminate the night sky in a frightening, homogeneous glow. The hidden glow across the sky is one of science's greatest discoveries. Before stars formed, the cosmos was a hot, dense soup of particles and radiation. Light could ultimately travel through space 380,000 years after the Big Bang when the cosmos cooled. The first cosmic flash occurred here. That ancient light still floods us from all sides. The universe has grown so dramatically over billions of years that the original white-hot glow has stretched by 1,000 times. It has moved from visible to microwave light, known as the cosmic microwave background. In the microwave spectrum, the night sky would appear bright golden. Every dark patch of sky at night hides the oldest light in time. Some of the static on antique analog TVs between channels is caused by this ancient radiation hitting the antenna. Old, weary light from the universe's expansion hides in a frequency our biological technology can't process in the sky. Stars fade, adding to the dark sky mystery. Classic Olbers Paradox believed stars were eternal and unchanging. We now know stars have distinct life cycles. They are born in gas and dust clouds, burn nuclear fuel for millions or billions of years, and perish. The first stars twinkled at the cosmic dawn, and the last stars will twinkle at the end of the universe. Many regions of space are black because their stars have burnt out, or their gas has not collapsed to generate new ones. Since star creation peaked billions of years ago, it has slowly declined. The universe is a flickering, changing scene. We see dark gaps because stars are far apart and not always on. All these pieces must be put together to understand why space is dark. 3 cosmic truths make up the answer. Due to the universe's finite age, we can only see a few stars nearby. Light from infinite distance hasn't had time to arrive. Second, cosmological redshift results from expanding cosmos. This distorts light from distant sources, making it invisible and energy drained. Third, stars are transient and unevenly dispersed. They are not eternal lanterns covering the universe. Combining these things creates the stunning, dark nothingness we see every night. Darkness is not information deficiency. It proves the universe has a past. Bright skies would indicate a static, unchanging, indefinitely old universe. The blackness indicates a universe that began, is growing, and is always moving forward. Dark skies can make us feel small, but they're gifts. It's the only reason we can see stars. The sky would burn us if it were a solid wall of light. The darkness lets us study the suns and galaxies that reveal our origins by comparison. Even glancing outside at night provides the greatest proof of the beginning of everything. We often think of space as an empty room, but it's actually a huge drama. Deep past and unseen present are revealed in the dark intervals between stars. Every clear night sky shows time and space stretching. You are seeing proof that our cosmos is living, active, and full of mysteries beyond our sight. The darkness is a curtain that hides the glorious story of how everything we know began.